1. Show that the equation 3 cos to the power of 4 theta plus 4 sine to the power of 2 theta minus 3 equals 0 can be expressed as 3x squared minus 4x plus 1 equals 0, where x equals cos squared theta. So what the question wants you to do is rearrange the expression 3 cos to the power of 4 theta plus 4 sine to the power of 2 theta minus 3 equals 0 into 3x squared minus 4x plus 1 equals 0 by using the substitution x equals cos to the power of 2 theta. So starting with the original expression, we want to use the substitution cos to the power of 2 theta equals x. So we need to rewrite this expression in terms of cos to the power of 2 theta so that we can use the substitution. So cos to the power of 4 is the same as cos to the power of 2 squared. So we have the first part written in terms of cos to the power of 2 theta. Now, we need to turn sine to the power of 2 theta into some form of cos to the power of 2 theta so that we can use the substitution. And the most common identity that we can use with trigonometry is cos to the power of 2 theta plus sine to the power of 2 theta equals 1. If you rearrange that for sine to the power of 2 theta, sine to the power of 2 theta equals 1 minus cos to the power of 2 theta. So we can use this to replace sine to the power of 2 theta in the expression and turn the expression into 3 cos to the power of 2 theta to the power of 2 plus 4 times 1 minus cos to the power of 2 theta minus 3 equals 0. And now we have everything in terms of cos to the power of 2 theta. So we can use the substitution x equals cos to the power of 2 theta to replace all the cos to the power of 2 thetas in the expression. If we do that, it turns into 3x to the power of 2 plus 4 multiplied by 1 minus x minus 3 equals 0. So if I expand the brackets and simplify it, it gives 3x squared minus 4x plus 1 equals 0, which is exactly the same as the expression given in the question. So that's done. Part 2. Hence, solve the equation 3 cos to the power of 4 theta plus 4 sine to the power of 2 theta minus 3 equals 0 for theta from 0 to 180 degrees. So this is part 2 of the question, and the first part asks you to prove an identity. It asks you to rewrite that expression as 3x squared minus 4x plus 1 equals 0. So you're not going to solve it from 3 cos to the power of 4 theta and so on. You're going to solve it from 3x to the power of 2 minus 4x plus 1 equals 0 instead, because they asked you to do that on purpose. So we're going to solve it using this expression, and later using the substitution x equals cos to the power of 2 theta to actually find the value of theta. So first, solve for x from 3x squared minus 4x plus 1 equals 0 first. So that's a quadratic. So we can solve it by factorizing. After factorizing, we get 3x minus 1 equals 0, corresponding to x equals 1 over 3, and x minus 1 equals 0, which gives x equals 1. And we know for a fact that x in this expression is equal to cos to the power of 2 theta. So using x equals cos to the power of 2 theta. Now we know that cos to the power of 2 theta equals 1 over 3, and cos to the power of 2 theta equals 1. To solve for cos theta, we can take the square root. So cos theta equals plus and minus the square root of 1 over 3, which is equal to plus and minus 1 over the square root of 3. And cos theta also equals plus and minus 1. So we can solve for theta from each of those by doing the inverse cos. So for cos theta equals 1 over root 3, theta is equal to the inverse cos of 1 over root 3, which equals 54.7 degrees. So every time you do inverse cos, you need to search for the other angles that might give the same answer as well that is in the domain. In this case, The domain for theta is 0 to 180 degrees, so we want to search for other angles that might give 1 over root 3 that is in the region 0 to 180 degrees as well. So one way to do that is to use a unit circle. So the domain is from 0 to 180 degrees, so we're looking at the top half of the unit circle only. So 54.7 corresponds to this line over here. And this is a positive cos, because cos theta equals 1 over root 3. Therefore, the other quadrant that gives the same answer would be here. So the other line that gives the same answer would be here. And it's not in the domain. Therefore, there's only one answer for cos theta equals 1 over root 3. We can do the same for cos theta equals minus 1 over root 3. So theta is equal to inverse cos of minus 1 over root 3, which corresponds to 125.3 degrees. So that angle is over here on the unit circle. And the other angle that will give the same value would be over here, because negative cos. And the other angle is not in the domain. Again, it's bigger than 180 degrees. Therefore, that's your only answer for cos theta equals minus 1 over root 3. Then we can do the same for cos theta equals 1. So theta equals inverse cos of 1, which equals 0. So 0 corresponds to this line on the unit circle. And therefore, that's the only answer, because the other answers wouldn't be in the domain. For cos theta equals minus 1, we can do the same as well. So theta equals inverse cos of minus 1, which gives 180 degrees. So 180 degrees corresponds to that. And there's no other line in the domain that gives the same value. Therefore, that is the only answer for cos theta equals minus 1. So we have 4 answers. Therefore, theta equals 0, 54.7, 125.3, and 180 degrees.